Welcome. Today we are diving into some of the features that really make Python feel like a superpower. These are the elegant shortcuts and powerful tools that, once you get the hang of them, will totally transform your code. It'll go from just working to being genuinely clean, efficient, and, well, Pythonic. So let's get right into it. We've got three main power-ups to unlock today. First, we're going to learn how to unpack values with this almost magical simplicity. Second, we'll build functions that are so flexible they can handle pretty much any number of inputs you throw at them. And finally, we'll master these quick, on-the-fly transformations. I'm telling you, nailing these three concepts will seriously level up your coding game. All right, our first power-up, it actually starts with something you might have overlooked before, the humble tuple. Yeah, it seems simple, but trust me, it's the secret key that unlocks some of Python's most elegant and powerful features. So what exactly is a tuple? Just think of it as an ordered collection of items that you cannot change. And that key word there is immutable. Once a tuple is created, it is locked in. You can't add things, you can't remove them. And that's not a limitation. It's actually a really powerful feature, as we're about to see. Oh, and a quick pro tip. While you'll usually see them wrapped in parentheses, it's actually the commas that technically make the tuple. This brings us to the classic question, when do you use a tuple versus a list? The huge difference is mutability. Lists can change, tuples are fixed. And because they're immutable, tuples are actually faster and more memory efficient. So you'd reach for a list when you need a collection that's going to grow or shrink. But for data that should stay constant, like coordinates, or even as a dictionary key, which lists can't do, tuples are the perfect choice. Okay, with that foundation, let's unlock our first Pythonic power-up, the clean swap. This is where we get to see how tuples let us write incredibly clean and readable code for a really common task. All right, picture this. You need to swap the values of two variables, A and B. In a lot of other languages, you have to do this clunky three-step shuffle with a temporary variable. You copy A into temp, then B into A, and finally temp back into B. It works, sure, but it feels clumsy, right? Now watch this. In Python, it's just A comma B equals B comma A. That's it. One single beautiful line. It's clean, it's perfectly readable, and it kind of feels like a magic trick. So, what's the secret? How is this actually working? The secret is tuple packing and unpacking. On the right side of the equals sign, Python sees B comma A and automatically packs those values into a temporary, invisible tuple. Then, on the left side, it immediately unpacks the values from that tuple into A and B. So it's not magic, it's just a brilliantly elegant use of tuples. And we can take this even further with something called extended unpacking. See that little asterisk on the middle variable? That's a super powerful signal to Python. It basically says, okay, assign the very first item to first, assign the very last item to last, and then just scoop up everything else in between into a new list called middle. This is so useful when you only care about the beginning or end of a sequence. Now for our next power-up, flexible functions using args and quargs. This is where you learn to write functions that can handle any number of inputs, which is a total game changer. Let's start with args. I want you to think of it as a catch-all bucket for positional arguments. When you put args in your function definition, it tells Python to collect any extra, unnamed arguments that get passed in and just bundle them all up into a single tuple for you. Just look at this total function. By using args, we've made it incredibly versatile. We can call it with 3 arguments, or 2, or 10. It doesn't matter. Whatever we pass in, args just collects them all into a tuple. In this case, 1, 2, 3, which we can then easily loop through. Now that is true flexibility. Next up is its partner in crime, quargs. See the double asterisks? That's our signal that we're now dealing with keyword arguments. This collects any number of named arguments, like name equals Akel or city equals Thrissur, and bundles them neatly into a dictionary. It's like passing a little Rolodex of labeled information into your function. Here's a great example. Our show profile function can now handle any combination of attributes we decide to throw at it. Double star kwargs just turns into a dictionary. Right here, it would be name/Akel city/Thrissur, and we can easily loop through the items to print out a nice, clean profile. Okay, a quick but very, very important rule. When you use all of these together in a single function, the order is mandatory. It has to be your standard arguments first, then start args and star quargs always comes last. Python relies on this exact order to figure out where everything needs to go. All right, time for our final power-up, the lambda function.
This is your go-to tool for writing quick, single-line functions right where you need them. If you work with data at all, you are going to see these everywhere because they are just so convenient.
So what is it? A lambda is just a small, anonymous, one-line function. Anonymous just means it doesn't have a name like a normal function defined with def. The syntax is really simple. You have the keyword lambda, followed by whatever arguments you need, a colon, and then a single expression. The result of that expression is what the function returns. That's it.
To really see why lambdas are so useful, let's look at a common task like sorting. Say we have a list of students, and we want to sort them by their score. The traditional way works fine. You define a separate function, getScore, just to tell this sorted function how you want to sort. But you have to admit, writing a whole separate function for such a simple, one-time task feels a little bit like overkill. Now, compare that with the lambda approach. We do the exact same thing in one clean, self-contained line. We create a quick, anonymous function right where we need it. Lambda x bar 1, this just means, hey, for any given item x, give me back the element at index 1. It's so much more concise, and it keeps the sorting logic right there where it's actually being used. It's just cleaner.
All right, you've seen unpacking, you've seen flexible functions, and you've seen lambdas. Now it's your turn to put it all together. Let's do a quick challenge just to help solidify these concepts.
Okay, here are 3 quick challenges. First, use tuple unpacking on that date to pull out the year, month, and day. Second, write an av function that uses star args to find the average of any set of numbers you give it. And third, use a lambda to sort that list of items by their second value. Go ahead and pause right here and give it a shot.
So there you have it, unpacking, flexible arguments, and lambdas. These aren't just tricks, they are the fundamental building blocks for writing truly clean, efficient, and expressive Python code. They let you write less to achieve more. So the only question left is, what clean, flexible code will you write first?